And welcome everyone. Today what we're going to see the basic and fundamental laws of absorption in UV spectroscopy. We are talking about the UV spectroscopy. There are some important laws which are given to explain the process of absorption. Generally, a sample that interact with the UV radiation, suppose this is a sample, it is interacted with the UV radiations. So the amount of light absorbed, it depends upon the certain factors like the length of this tube. Let's example, this is a tube, so the length, the concentration and the intensity of incident radiations. So these are the some important factors which are influenced. So first fundamental law of absorption is given by Lambert's law. Second law is given by what, the Beer's law, and we have Lambert-Beer's law. With respect to fundamental laws of absorption, you must know some terms. Let's example, what is the transmittance? One is called the transmittance. Transmittance is the ratio of intensity of light transmitted by the sample to the intensity of incident radiation of the sample. Now means the transmittance is basically the ratio of intensity of transmitted radiation to the what, to the intensity of incident radiation. So that means I by I0, and generally it is expressed in percentage. कैसे डिनोट करते हैं उसको अपन, परसेंटेज में. That is the percentage of transmittance is equals to I by I0 into what, the 100. Means if the transmittance is 100, then absorbance will be a 0. So with respect to that, we have simple plots, percentage of transmittance with respect to that length. Okay, this is the first parameter which is related to the absorption, right? Now the second parameter, that is called as a absorbance, right? The second parameter, that is called as a absorbance. Now in absorbance is basically what, it is a reciprocal of transmittance, or we can call, it is defined as the log base of the reciprocal of the transmittance. That means denoted by A, which is denoted by A, and that is nothing but the log of 1 by T. Okay, so you can also take the log base of the transmittance, that is negative log base of the transmittance. So A is equal to minus log of T, and you know about the T is equals to I by I0. Means you can solve this simple equation, that is A is equal to minus log of I by I0, or we can call log of I0 by I now. Okay, so this is also the equation of the absorbance. Okay, and absorbance and transmittance both are the different terms. Okay, so if transmittance is 100, then absorbance must be a 0. If absorbance is 100, then transmittance must be a 0. The next important term, that is called as a molar absorptivity, and which is denoted by the epsilon. Okay, so the epsilon is called as a molar absorptivity, and it is generally proportional to what, the molar extinction coefficient. Okay, we can also be called to this, and which is generally proportional to the absorbance and inversely proportional to the length and the concentration. So this is the third important parameter which is required for the fundamental process of the absorption. Okay, so now we are moving to the first law of the, one can call the absorbance, and that is called the Lambert's law. According to Lambert's law, talking about the ratio, or talking about the relationship between the intensity of incident light, okay, and the thickness. So when a beam of monochromatic light is passed through a pure homogeneous medium, we are passing that homogeneous light through the what, homogeneous medium. This is what homogeneous medium. The decrease in the intensity of light with respect to what, the thickness of the absorbing medium, let's say x, which is proportional to what, the intensity of the incident light. So that means minus di by dx is proportional to I. That means that minus di by dx is equal to ki, where k is a constant. We can also call it as a molar extension coefficient, that is epsilon also we can take, okay. And that equation can also be roughly indicated as a minus di by dx, तो हम इसको लिख सकते हैं, and minus di by dx is proportional to I होता है, और minus di by dx is equal to ki होगा या फिर epsilon I होगा. Now see, di by I is equal to minus k dx, where k is a constant, where what, the k is a constant, which is called as a absorption coefficient, और उसको ही क्या कहा जाता है, extinction coefficient, okay. This is what the law which is given by what, the Lambert. और उसको और भी आप आगे सॉल्व कर सकते हैं. वहाँ पर x जो है वो आपका एक पर्टिकुलर इंटेंसिटी ऑफ लाइट रहेगा एट, और x माने क्या होगा, आपका डिस्टेंस रहेगा. द मूविंग टू द सेकेंड लॉ ऑफ द एब्जॉर्प्शन, दैट इज कॉल्ड द बियर्स लॉ, जिसको प्रपोज किया था बियर ने in 1852. According to the Beer's law, when a beam of monochromatic radiations, when what, the beam of monochromatic radiation passing through a solution, the decrease in the intensity of light, with the thickness of the solution, with the what, thickness of the solution, and directly proportional to the intensity of incident light as well the concentration of the solution. Means किसके किसके प्रोपोर्शनल रहेगा, इंटेंसिटी जो है ये डिपेंड करती है थिकनेस इन्वर्सली प्रोपोर्शनल और कॉन्सेंट्रेशन डायरेक्टली प्रोपोर्शनल. सो दैट्स वाई वी हैव दिस इक्वेशन माइनस डी आई बाय आई इज प्रोपोर्शनल टू डी सी, और माइनस डी आई by I is equal to EDC now, sorry, epsilon D and C, where that epsilon is a molar absorption coefficient, right, and C is a concentration, D, or we can take the L, that is a length, okay. This is called as a Beer's law. Moving toward the next one, that is combine Beer's-Lambert's law, and according to this Beer's-Lambert's law, the intensity of light transmitted by the solution, देखो intensity of light which is transmitted by the solution, by the solution is depend upon both, that is the, एक किस पे डिपेंड होगा, एक तो कॉन्सेंट्रेशन के ऊपर भी डिपेंड है आपका, और दूसरा होता है आपका पाथ लेंथ. किसके ऊपर डिपेंड है आपका, ये पाथ लेंथ ऑफ द सॉल्यूशन. यानी कि A जो रहेगा आपका, A इज इक्वल टू, दिस इज एब्जॉर्बेंस विच इज इक्वल टू log ऑफ I0 by I, और बेसिकली इसको हम कैसे लिखते हैं, A इज इक्वल टू द एप्सिलॉन L इंटू सी नाउ. और इफ़ अगर हमने 1 मोलर सॉल्यूशन अगर हमने लिया है तो वहाँ पर आपका पाथलेन जनरली हम कितना कंसिडर करते हैं, 1 सेंटीमीटर कंसिडर किया जाता है, राइट. सो दीज आर द 3 इम्पॉर्टेंट, वन कैन से द फंडामेंटल लॉज ऑफ द एब्जॉर्प्शन. हाँ, इसके लिमिटेशंस भी हैं. लिमिटेशंस ये हो सकते हैं यहाँ पर कि जो कॉन्सेंट्रेशन वर्सेस एब्जॉर्बेंस का जो ग्राफ लिया जाता है वो पासिंग थ्रू द ओरिजिन सॉल्यूशन होता है, ठीक है, पासिंग थ्रू द ओरिजिन. एक ये भी डेविएशन है उसका. एक तो लाइट ऑफ अ सिंगल वेवलेंथ इज यूज्ड, ये भी एक उसका डेविएशन हो सकता है यहाँ पे, ओके. सो सम आर द डेविएशंस आर देयर नाउ. सो दिस इज व्हाट द लॉज ऑफ, वन कैन से द फंडामेंटल लॉज ऑफ द एब्जॉर्बेंस नाउ. और ये जब भी आप यूवी स्पेक्ट्रोस्कोपी पढ़ोगे तो तब आपको ये बेसिक कंडीशन आपको सबसे पहले पता होनी चाहिए कि लैम्बर्ट्स लॉ क्या कहा जाता है, बियर्स लॉ क्या किसको कहेंगे अपन, और दूसरा होता है आपका बियर लैम्बर्ट्स लॉ, ओके. सो और इसके ऊपर छोटे आपको न्यूमेरिकल्स भी आते हैं. सो विल सी द न्यूमेरिकल्स इन द नेक्स्ट पार्ट, ओके. थैंक यू.